Yes. Now, if you are not in a comfortable place, go to a comfortable place and have a drink if you want. Sit back. Because we are going on an endless journey together, there are two possibilities at the end of the video. You will either completely forget who you are and where you are, or on the contrary, you will find your true self. Are you ready for an existential journey? If you have completed the subscription process, we can move on to the video. According to the latest estimates, the universe, which was born 13-odd billion years ago, is 46 billion light-years in diameter. If you ask how it is 46 billion light-years in diameter, this is related to the expansion rate of the universe. As we know, the universe has been accelerating for a very long time. In other words, the speed of light is for the universe, is not the limit. We can also talk about it, but now, when we say 46 billion light-years, we say it is quite big. But it is really difficult to perceive and understand these types of numbers, these distances. We need to concretize it. We will do this today. How big is the universe? Why? We will talk about it at the end of the video. If you are ready, let's start first. Let's start from our pale blue dot world, which we are on at the 0 point. Actually, we do not live on a very small planet. To make it concrete, for example, if you get in a car, it will travel around the world at a speed of 100 kilometers per hour without stopping, and you will have to travel more than that day. If you think this would be too tiring, you can hop on a passenger plane. If you do, you still have to travel more than 2 days. That is, we do not live on a small planet at all. We have been traveling for hundreds of thousands of years. We settle on this rocky planet. We live and die. We still haven't finished yet. Many people's lives end in a very limited area, without even seeing other cities, let alone continents. Anyway, the limits of our minds are the limits of our minds. No, but right? Let's leave it to our closest neighbor to the Earth. Let's go to the photos, animating it. Month. When we look at the animations, it looks like it's right next to us, right? It's like we could touch it if we stretched out our hands on the full moon. However, there are 84,400 kilometers between us. Should we jump in the car again? Let's say we built a road to the moon, and again, he drove at a speed of 100 kilometers without stopping, without taking a toilet or lunch break. It would have taken us more than 6 months to reach the rock. Even if it wasn't 6 months by car, we reached here. It is the farthest place humanity has ever reached on the cosmic scale. 12 people have walked on it so far. It is amazing, but we have time. Let's continue our room. When we expand a little more, we see other planets. When we see them in animations, they seem very close to us. But of course, it is irrelevant. It is not possible to show the actual size. The solar system is a tiny part of the universe. In fact, it is gigantic. Let's get in our car again and try to go to the sun at a speed of 100 kilometers. We could have been in about 177 years without taking a lunch break. If we said let's go by plane, it would take exactly 19 years to the sun, which we think of as if it were eaten at the bottom. Well, if we said let's give up and go to Neptune, that would be even more of a problem. By car, again, without a break, it would take more than 5,000 years. By plane, it would take 600 years. So yes, the solar system is quite big. That's it. That's why just colonizing the solar system is huge. It's not like we pushed these limits. Even if we can't go there, the vehicles we built have come a long way. Because these vehicles can move much faster than a car or an airplane, 40000 kilometers per hour, sometimes even faster. The most distant object as a human-made vehicle is Voyager, which was launched in 1977. It has been heading towards the depths of space at full speed for more than 43 years. It abandoned the solar system. So, if it could travel at the speed of light, it would take 21 hours to reach Nizwa-Sirbir. By the way, you can still follow the current location and route of that ECR on NASA's website. Well, it is time to leave the neighborhood slowly. Let's get out of the solar system, but there is a problem. Where is the border? There is no clear answer to this for some. According to some, this is the orbit of Neptune. According to some astronomers, the answer to this is a belt with billions of comets known as the Army Cloud. Of course, this uncertainty corresponds to incredible distances. Let's say Neptune is the border of our solar system. In this case, if we could move at the speed of light, we could be in 4 hours. But if we try to draw the border from the North Cloud, a little outside, This time, when we set off from the Sun, it would take exactly 1.5 years with the light trail to reach here. That is, 1.5 years depending on where you draw the border. To remember again what kind of speed the speed of light is. With its speed, it can travel around the Sun for 8 minutes in 1.3 seconds. It seems like, if we reach the speed of light, will we solve everything? Even reaching the outside of the neighborhood, even this fast, will take a year, we will understand. Anyway, I think I don't need to say that we are just getting started. We haven't come even an inch from a cosmic point of view yet. It's amazing. When we compare our solar system, which seems to be a lot in size, with our galaxy and the Milky Way, the limits of our minds will begin to be pushed even more. Now, the closest star to us is Proxima Centauri, which is about 4.2 light years away. Actually, let's get in the car and then try to finish it. How long do you think it would take if we went at a speed of 100 kilometers per hour without taking a break? Approximately, it would take 47 million years. We are in a hurry. If we say, let's get on a plane, we are in a hurry for 5 million years. Let's jump on a space shuttle, for example. If we travel at the same speed as a painter, it would take 73,000 years to go to the nearest star to our neighbor. That is, it is not too bad, but if we calculate the human lifespan at this speed, this means even 2,500 generations. This is a little further away. The brightest star in the sky is Siri. It is 108 light years away. As we move a little further away, we see a larger neighborhood of stars. There are 52 star systems in this region. Some of them are a little faint. That's why we can't see, but there are some stars that are much farther away. We can see it more clearly. For example, we are traveling with it. Even though it is 645 light years away, we can see it quite easily, because it is a star that is 1,000 times larger than our Sun. But when we look at our own interstellar system, we have a system with a diameter of 50 light years. It is a huge system that we can reach. When we leave this system behind, we reach the radiosphere. When we say radiosphere, we are talking about the place where human communication and the radio waves it has spread since the Second World War can reach. This corresponds to such a place. It is talking about this blue dot. That is, the waves we have spread since the invention of the radio, it has just reached the upper constellation. If there is a civilization in a more distant part of the Milky Way, we have not even heard of it yet. There are 3,000 to 5,000 stars in a small area, and in this area we call the radiosphere. It has a diameter of 160 light years, but let's get out of here. It is about 1,000 light years. Isn't it very, very far away? But no, it's not even 1% of the Milky Way galaxy. Unfortunately, it's just our galaxy. Can you imagine how big it is? It's a single galaxy with an estimated 400 billion stars. And what we call a billion is a human being. Wow, that's a lot. I'm thinking again how big a billion is. I want you to think about it, for example. It takes 17 minutes to count up to 1,000. It takes 17 hours to count up to 1,000,000. If you try to count up to 1,000,000,000, do you know how much it takes 32 years? Yes, that's a big number somewhere, and it takes 100 to 200 billion or so. I can explain what we are talking about when we say 400 billion stars. The situations I want to emphasize, because things get more complicated. So there are about 400 billion stars in our galaxy alone, and assuming that each star has a planetary system, we are talking about billions of trillions of possible planets. And there is only one galaxy that contains all of these. Never mind the numbers of 1,000 light years in diameter and 1,000 light years in thickness. Let's put it this way. Let's say that our solar system is the size of a cent. For example, we can say that the Milky Way is almost the size of the American continent. Searching for a needle in a haystack is not a child's play. And don't forget that there is on this cent in our world. It is probably a grain of dust that cannot be seen with the naked eye. Yes, we are on that dust grain. And this is just a comparison of our solar system through straw. So let's continue. Let's even break the ropes and get out of the Milky Way to the neighbor Andromeda. Let's go to Andromeda, which is 2.5 million light years away. Let's cross it. It expands to a diameter of 110 million light years. In front of us, we see the Virgo supercluster, which includes the group of galaxies called the local group, where they are located. There are thousands of galaxies in it, thousands of galaxies containing hundreds of billions of stars and trillions of planets. There is no stopping. Let's move further away. We will see other superclusters like the Virgo supercluster. Some parts are dark. Because the Milky Way galaxy covers this part, we cannot see it. As we move further away, we encounter quasars, which are extremely bright. Galaxies formed in the young periods of the universe. Finally, we come to the map of the radiation left over from the Big Bang, which we call the cosmic background radiation. When we look here, we actually reach the limit we call in the observable universe. This is the limit, consisting of the last objects and the giant system with about 2 trillion galaxies in it. 2 trillion is not there anymore. I think there is no need to explain the size of the numbers. Here is everything. Well, no, of course. For now, we think that the observable universe is 46 billion lights in diameter. We do not know beyond that, but as we talked about before, the universe is expanding at an accelerating pace. When taken into account, it is thought that the diameter of the actual universe could be 250 times larger. We are talking about trillions of light years, and now the real question is, what should we do? What can learning this do to a person? The answer to this question is very personal at home, but for all the great names in history, philosophers, thinkers, scientists, the answer to this question is actually everything. The answer is because man's effort to understand himself by trying to understand the universe. In fact, the better we understand the parallel universe, the better we understand ourselves. Yes, we are not actually trying to understand the universe. The universe is not a phenomenon that you can think of separately from ourselves. The universe is us, and we understand the universe. We are connected as a whole with our world, and atomically with the entire universe. And in this consciousness, there is a knowledge that can change everything in every sense. This consciousness tells us that we should approach all living things and the environment with respect and love. We may seem very small and insignificant, but it also tells us that we are special, every atom in our body. Knowing that it came from stars that died in time ultimately tells us the insignificance of fights, wars, and simple troubles. Our time is limited, and we need to use it very well as always until we meet again. Thank you for having us. Best regards.